Okay, we're going to review solving some consecutive integer problems. The first problem says find the largest of three consecutive even integers if the sum of the first and second is 10 more than the third. So we're going to start by circling and underlining keywords. We're looking for the largest. There are three of them. They are consecutive even integers. And the sum of the first and second is 10 more than the third. Okay, we know that is means equal. We know that sum means we're going to add. If we have three of them, we have the first one, the second one, the third one. We're looking for the largest one. So that would be the third one, would be your largest one. And they're even, and even integers increase by 2. So the first one is n, the second one is n plus 2, and the third one is n plus 4. Now it says the sum of the first and second. So that's first plus the second is equals 10 more than the third. More than means to add. Now in place of the first one, we're going to put n plus the second one is n plus 2 equals 10 plus the third one, which is n plus 4. Combine your like terms. 2n plus 2 equals 14 plus n. We're going to use our properties that we learned with solving equations using the subtraction property here. You're going to have n plus 2 equals 14. Then I'm going to subtract 2 to solve for n, which is a subtraction property again. And I have n equals 12. Go back up here. Here's n. So the first one is 12. The second one is going to be 12 plus 2, which is 14. And the third one is going to be 12 plus 4, which is 16. And this is the one they want us to find. So the largest integer then is 16. Okay, the second problem says to find 4 consecutive odd integers if twice the sum of the third and fourth is equal sum of the first and second. Okay, so here we have 4. So it's first, second, third, and fourth. They're odd, and your odd numbers we know are 1, 3, 5, 7. And even though they're odd, they are increasing by 2 as well. So your first one would be n. The second one is n plus 2. Then I have n plus 4. I don't know what's going on with this focusing. And then the fourth one is n plus 6. Okay, so it says twice the sum of the third and fourth. So that's 2 times the third plus the fourth is equal to the sum of the first and the second. Okay, so now it's 2 times n plus 4 plus n plus 6 equals n plus 2. Combine your like terms. That's going to give us 2n plus 10 here, 2n plus 2. Now we're going to use our distributive property. 4n plus 20 equals 2n plus 2. I'm going to use the subtraction property to get my like terms together. And I'm going to get 2n plus 20 equals 2. Okay, and then we're going to subtract 20 from both sides. And we get 2n equals negative 18. So I have 2n equals negative 18. I'm going to divide by 2. And I have n equals negative 9. So here it says to find 4. So we got to find all of them. Okay, the first one is negative 9. And this one is going to be negative 9 plus 2, which is negative 7, negative 9 plus 4, which is negative 5, and negative 9 plus 6, which is negative 3. So the four integers are negative 9, negative 7, negative 5, and negative 3. Okay, for the third problem, it says find 3 consecutive integers such that 3 times the smallest is 14 more than the largest. Okay, so we have 3. So that's automatically first, second, and third. They are consecutive integers this time, and consecutive integers, they increase by 1. So the first one would be n. This focusing is really not a great. Okay, the first one is n. Second one is n plus 1. Third one is n plus 2 because they're consecutive and they're going to increase by 1. Then it says 3 times the smallest. Well, if they're in order, this is the smallest, and the third one would be the largest. Okay, so 3 times the smallest, that's 3 times the first one, is equals 14 more than the largest one, which is the third one. So that's 3 times n equals 14 plus n plus 2. And if you notice, we did not use the second one to create the equation, which is fine. We don't have to always use all of them. So I have 3n equals 16 plus n. We're going to use that subtraction property again to isolate the variable. 2n equals 16. Divide by 2. And I get n equals 8. Now the problem says to find the 3 integers. So the first one is 8. The second one is going to be 8 plus 1, which is 9. The third one is going to be 8 plus 2, which is 10. So those 3 integers are 8, 9, and 10. Those are your 3 integers. So when you're setting these up, it's very important that you read the problem carefully because you don't always have to use all of the terms. Okay, here's the last one. It says find 3 consecutive multiples of 7. So now we're talking about multiples of 7. Multiples of 7 means that each time the number is going to increase by 7. And we have 3 that we're going to find. So I'm going to write first, second, and third. The first one is always n. The second one this time is n plus 7. For the third one, I'm going to increase by 7 again, and that gives me n plus 14. And then it says if their sum is equal to 105. So it's going to be the first plus the second plus the third equals 105. So the first one is n. The second one is n plus 7. The third one is n plus 14 equals 105. Okay, we're going to combine the like terms that are on the same side. And that's going to give us 3n plus 21 equals 105. And then we're going to use our subtraction property, and we're going to subtract 21 from both sides. And it's going to give us 3n equals 84. And now we're going to use our division property, and we're going to divide by 3. And I get n equals 28. So the first thing I do is I look at 28 and I ask myself, is 28 divisible by 7? And the answer to that is yes. So now I'm going to use 28 to find the second and the third number. Right? The first one is 28. The second one is 28 plus 7, which is going to be 35. And the third one is 28 plus 14, which is going to be 42. So the 3 consecutive multiples of 7 are 28, 35, and 42. Now, these problems can be very simple. The important thing is that we read them carefully when setting them up.